Okay, today is October 12, 2021. This is Tuesday's lab on second law of motion. Okay, I'm going to brief you quickly how you're supposed to do. In this experiment, we are going to use the Atwood machine to verify Newton's second law of motion. And the way I'm going to do, I'm going to use a clamp, attach the clamp to the to the table that you have. We're also going to use a rod, clamp the rod to the clamp table, and you're going to use a pulley as well, a pulley that can be clamped to the top of the rod. This, on the top of that, you're going to get two mass hangers connected by a string, and you're going to pass the strings through the pulley. Okay, you're going to put one of the mass hangers is going to be a given height h, and the other mass hanger, the mass 1, is going to be just above the ground, barely touching the ground. Measure this height of the mass 2. You should be using the same height throughout the whole experiment. Okay, that's your system. The two masses are connected by the string, and that's considered the system. Okay, and the forces applied to the system are the weight of the two masses. And the way you're going to do this experiment, you're going to load a total of 500 grams here on mass 1 and a total of 500 grams here on mass 2. 500 grams on mass 2, and then you're going to add a little bit of masses here according to what is there in the lab manual, okay? Because this mass is heavier than mass 1, the system is going to accelerate. Mass 2 is going to accelerate downwards, mass 1 is going to accelerate upwards. When you put the masses, the slotted masses here, make sure you use tape to wrap the masses in the vertical direction. So the masses, the slotted masses, are very secure in the mass hanger. It's very, this experiment is kind of dangerous because if you don't wrap the masses with the tape, as the masses are descending given acceleration, they can fall apart and fly into our foot, okay? Think about that half kilogram hitting you at a given speed. You don't want that, okay? That's why it's very important for you to wrap the masses in the vertical direction to secure the slotted masses in the mass hanger. So the experiment consists in timing how long this mass 2 takes to reach the floor. You already have the h, the height of the masses, right? You're going to have the time as well. And here's the simulation, what's going to happen. Here you go. Repeat that for 6 different masses. You might need to repeat the timing 3 times for each mass. When you repeat, here you go. You're going to do for, let's say, 550 grams here, right? Time it, how long it takes. Bring the mass up again. Take out, let's say, 10 grams of mass 2 and load into mass 1. Now you have 540 here and 510 here. Repeat the experiment. It's going to have a different amount of time, and so on. Okay, that's what the experiment consisted of. The friction is considered to be negligible. If there is any friction, there is a way to perform this experiment, even with friction. And just come by and talk to me about that if you're having any problems timing the masses. Here you go. Here's the tables. Here you're going to need the acceleration of gravity. You're going to need the mass m1. You're going to start with 500 here. You're going to start with 500 and something else. Okay, so I'm going to tell you exactly the values. You're going to measure the height. Hopefully you're going to have the same value for the height 6 times. Here it's going to be T1, T2, and T3. Make repeat the experiment 3 times to get 3 intervals of time. And here is the mass 1 plus mass 2, which should be constant. Okay, you're keeping mass 2 heavier than the mass 1, but the net mass of the system should be the same. Okay, and then we're taking the average. We can calculate the acceleration using the kinematics equation. Here's the difference between the masses, and here is the net force applied to the system, which is the difference between the masses times the acceleration of gravity. Let's take a look at the note. We go. Here's the theory behind the experiment. You're going to measure mass 1 and mass 2 with the same scale that you used before. Has a resolution of 100 of a gram. And when you change it to kilogram, you get this small number. And don't forget the significant figures there. You're going to use a meter stick to measure the height of mass M2 with a resolution of 1 millimeter or 1,000th of a meter. Again, here is the significant figures that you have to have there. And you're going to use a timer to determine the fall of the heaviest mass with a resolution of 100 of a second. Repeat 3 times. Here are the equations that we use using Newton's law. Net force is going to be weight of the 2 minus the weight of 1. Net mass is going to be mass of 1 plus mass of 2 times the acceleration of gravity. Not the acceleration of gravity, the acceleration of the system. The acceleration of gravity goes only in the left side of the equation. Here's the net force. Here's mass m times a. Okay? What we are going to do, we are going to determine the acceleration of the system by measuring the time it takes for the mass to reach the floor. Okay? And what we are going to do, we are going to plot this force here against A. You are supposed to get a straight line with a slope of m1 plus m2. Okay? So here's one example. Start with mass 2 equal to 580. Okay, here you go. I have numbers here for you. 500, around. Those numbers are not written in stone, okay? But it should be around 580 grams. Okay, 580 whatever grams. And mass 1 should be 550, roughly 550. In this case, I have 552. You can have different numbers, but don't make too much of a difference. Don't make this one too heavy to the point that the mass is accelerating too fast and you cannot time the amount of, you cannot have a period of fall long enough, okay? Here you go, the acceleration is given by 2h divided by t squared. And that's what's already programmed in the spreadsheet. Okay, plot m2 minus m1g along the y-axis and a along the x-axis. That's the whole idea. And the slope of the graph should be equal to the net mass. Okay, that's the experiment, and I'm going to stop it here and upload to my YouTube channel.